So yes guys, so welcome to CPP Byte. So in this video let us talk about nm command. So what this nm command does. So in order to understand, as usual, let us try to create an example. So here I'll create int min as usual. So std out hello world \n. So then what I'll do is I'll create some of the variables. So I'll say int g underscore a, so maybe int g underscore b. So I'll initialize this one with 10. Then let me create one example. Int add int a comma int b, then I return a plus b. So then let us try to same std cout sum of 10 and 20 is add 10 comma 20 \n. So this is a simple example which I am creating. So then what I do is I'll go here and I'll compile main.cpp. So once I compile this one, so I execute this a.out. So here as usual, so sum of 10 and 20 is 30 and hello world is getting printed. Now let us execute nm command nm a.out. Enter. So whenever I do nm a.out, what exactly it is doing is, here you can see, so there is a g underscore a. So g underscore a is which is present here. So this g underscore a is marked as b. So that means it is present in a data segment, but it is uninitialized data segment. So that means I did not initialize with any value. By default, it is initialized to a 0 because it's a global data. So that's why it is called as B. So this is uninitialized data segment, or it is also called as BSS segment. And one more thing is G underscore B. So since I have initialized this one, so this is going and sitting in my data segment. So this is where G underscore B is present. Now where is my function add? So I'll scroll down here somewhere. Can you see here? So there is a capital T and there is something called underscore z3 add ii. So this is basically a function which is present. So this is called a symbol. So basically this nm command prints all the symbols which is present in my executable, which is nothing but a.out. And here the capital T represent, it is present in my text segment. So that means it is a part of my code base, right? And what exactly it is. So this is called name mangling. So what I do is, so I can say nm a.out and I can say demangle. So whenever I do a demangle, if you scroll down here, can you see there is an add? So the parameter is integer and the one more parameter is an integer, and the return type, you do not specify any return data types. So this is what exactly internally it looks like. This is called a symbol table. Now what I'll do is, so I'll create one more function. So let me say integer, or let us say double add double a comma double b, similarly return a plus b. So simply I'm creating one more function here. So what I'll do is, again I'll go back to my terminal, cg++ main.cpp, again execute nm a.out ---- demangle. Instead of demangle, let me execute with nm command itself. Now if I scroll above here, can you see? So there is a name, the function name is getting changed. So earlier it was add ii. So underscore z3 is appended with all the function name, and also there is a 2dd. So one d representable, another d is also on double, since it is taking 2 parameter. Now let us execute again with --demangle in order to prove that. Again go back here, and can you see here? So there are two functions called add. So one is taking integer and another one is taking double. So from this one, what I can say is, so simply by mangling the name of the function, so we are introducing something called overload. So here you can see I created an overload function, but the similar kind of things is not available in C program, right? So since it is a C++, this is available. What if it is a C program? So in order to make that one simple, I'll say extend C. So I put a extend C for both of them. Now what I'll do is I'll go here and let me compile this one again. If I compile this one again, can you see here? There is a conflict declaration of C function. Can you see? It is representing as a C function. So which is int add, which is taking 2 integer. And also it is saying it is already been previously declared here. So here we are declared as a double. Now what I'll do is, so I'll simply remove one and I'll compile this one. Now can you see? Now it is working fine. Now again I'll say nm a.out. Now if I do this one should be name mangled and another one should not be. So I'll scroll down. So here there is a name mangled function which is taking 2 integer here where it is. Then there is a double. So there is one more add function. So where is that add function? So let us search for this one. Here you can see. So here you can see this is only an add function, but there is no mangle for it. So in order to see what exactly it is taking, so simply do --demangle. So even though if you do a demangle, so this is what internally it is represented by but here you can see simply it is an add. So this is the difference between the name angle in C and C++. So what exactly the C++ guys are doing is, so simply by adding a different name to a function, they are introducing so many different features of a C++. So one among them is a function overload. So the same thing is happening with a function override as well. So this is how internally C++ is a C program internally, just by adding some of the extra thing called name angling. So this is what about the nm command. So in order to just strip off the things, so one thing what you can do is, so you can execute strip a.out. So now if you do nm a.out, here you can see there is no symbols, but you can see the dynamic symbols using -D enter. So now if you do this one, what are all the functions which is been coming from the different compilation unit? So maybe one may be from some other library. So that is what it is all printing. It is not printing the compilation unit or the function which is present in the same executable, which is nothing but a.out, because during the compile time itself already the linkage is happened. So the loader already links, okay, this add should call to this one, the address is already resolved. So now again if I do -d mangle, here you can see so internally the operator overload. So whatever I am printing here, so this is what it is getting printed, and it is undefined, and the function definition is present in libgc. So basically it's a C++ library. So this is where it is present. So this is what about nm command. So in the next future video, let us talk a little bit about how can you see the nm command with the shared library basically. So all those things we'll see in the next upcoming sessions. So as of now, this is what the nm command does. So nm command is used to print the symbol table of a executable. All the symbol tables which is present in the executable is getting printed, and this symbol table is used for debugging purpose. So that is the main purpose of using a symbol table. So nm command is used to print those symbol table. This is all about this video base. Thank you.